So today I'm going to show you some basic lighting setups in Unity. The lighting in Unity can be a little bit tricky. We're also going to go through a little bit of animation using the new timeline function in Unity 2017. So in Unity, the first thing I've gone and made just a blank scene. In that scene we have a camera, a main camera, that's tagged main camera, and then a directional light. The directional light has a little bit of a yellowish color to it. Let me put in, so if you go Game Object 3, 3D Object, and we'll put in a plane. Set it to location 0, 0, and 0, just to get it centered in the world. And then we'll scale it up really big. Just to make it easier to see, I'm going to go ahead and just put a material on the plane, a checkerboard material. I'll show you how to make that. So I've got a bunch of folders in my assets here. I'll go ahead and take those out or close them for now. And then I've made a folder called Materials. So in the Materials folder, I'm just going to go Create, right click in the folder, Create, and then Material. We'll give it a name. We'll call this Checker Floor. And then take that and drag it onto the plane. Now you're not going to see anything because we haven't had any texture maps to it. So in the inspector window over on the right, if you click on the Albedo, which is diffuse for other materials, the standard shader, which is what this you should have it set at, there's a bunch of other types of setups for shaders as well. These are based on whatever packages you've imported, but also some standard shaders that are just in Unity. You're going to see those if you change it, but standard is the one we want because it's got the most options for being able to get a good realistic environment set up. So for the albedo in this checker floor pattern, click on that and you're going to get a window, a texture pop up. If you just search for checker, it should show up. So there's a checkerboard and a checker. Let's try checker. And then, well, checkerboard. Yeah, checkerboard looks good. So now it's kind of big in terms of the spacing, but we can fix that. So one of the ways we can determine how big we want this is I've got a character imported in, the Atom character, in this Atom character pack. So I'm going to use him as a reference. Select this folder, and then we'll just pull him out into the window. And then so you can see these checkers are really big. They're kind of blurry too. So if we select the floor with him standing on it, open up our checker floor setup, and then down here under tiling we can make it tile, let's say 10. And the reason it's so big is because I've applied it and scaled the plane so large. But you can just make it repeat. It's a tileable texture, so let's go 20. I'd like for these checkers to be about 1 meter across. Right now they're about 2¼ Let's do 25. So if we, yeah, that looks still 2. So let's make the size 100 up here under the transform. So we'll make it 100 so we can start to get an idea for actual scale and be more precise. Alright, so it's 100, 100, 100, which will make this tiling amount be relative to the actual scale. So if we set, let's actually make it 10 just to get an idea for how big this. So 10 by 10 by 10 would be a 10 meter plane. And then if we set our tile to 1, we'll get an idea for what, it's actually more than a 10 meter plane, so it's like 100. So if we set it for 1, I'm guessing 1 the scale would be 10 meters. Yep. Alright, so now, which means that our checkerboard is, looks to be like a ½ meter for each check, roughly. And so what we can do is, if we scale, so at 1 by 1, if we go 10 by 10, so that's 10 meters. Let's do, yeah, 1, 2, 3, 4, 5, 6, yeah, 7-ish, 8. So let's do 10 on the scale. We don't need to make it too big. I'm just showing you how to kind of get an idea. Unities in meters. So showing you how to get an idea for scale relative to your texture, because otherwise it can cause things to be off in your scene when you actually go to render it. That's pretty good size. It's going to allow the background to show up, but we don't really care about that right now because we may have it blocked out by other things that we put in the scene. So at that, so I've scaled it up by 10, so that means if we want to get our scale back, then we scale it this to 10. So now we're back to our tiles at the right size. So this will be our basic floor. There's other things that we can do with the shader map. We're going to show you more about that when we add more objects into the scene. But for now, if you take this metallic option, if you take the metallic and crank it up, not much changes. It gets darker, and the reason it doesn't change is because we don't really have any reflection. But if you crank up the smoothness, so these are like metallic functions. So metallic means how reflective is it. So if it was completely reflective, like a mirror, it'd be 1. And if it was completely smooth, then that's a mirror. And what you're getting, we don't really see it because we only have like this gradient of a sky. So we can fix that by going to, if you open up Window and Lighting, Settings. I already had it up here in a tab, but it's the Lighting Explorer. If it opens up a window, you can just drag it over and create a tab here because we're going to come back to this. But we can set a Skybox Texture. So what we have is a Skybox Material and a sun source light. So we're going to make our sun be this directional light. So if you just grab that and drag it over. And then the default Skybox is this gradient. So we can, if we click on the little target next to it, we can type in Skybox in the select material. And you're probably going to have a few. I've got a couple. So I've got this start day, which brings up these clouds. Sky 1, which is sort of foggy, reddish, kind of polluted. And let's see what else. We've got procedural, which is another gradient. Sun, I'm not sure what that is. That's a different box. So this default one has some clouds, or not. You may not have this one. This is part of another map or another package that I've opened. And the same thing with the morning one. I'm going to go with the morning one. I like the colors. So if you want to get that, then you can download it off of the Unity store. It's like a free Skybox. So Sky Start Day. So if you go to the Unity asset store here and you type in Skybox, it'll come up and you'll see the first one is this Skybox free texture. There may be some other ones in there as well. You can download, you can create your own using Skybox. We're not going to go into that for this tutorial, but so I want this, and you'll see once I've added that Skybox that now with my floor cranked up, I'm getting a reflection of the Skybox in the floor, like it's a mirror. which, you know, I don't want it to be that reflective, but I just wanted to show you that that'll reflect, and we can actually get more reflections in the scene when we start to set up the lighting rigs and other lighting options here at the end of the tutorial. So for now, I'm going to go back to the inspector, select my checker floor, and I'm going to pull this down. I'm going to make it a little bit reflective, and I'm going to blur it a little bit. That's the other thing, is if you change the smoothness, so you see how the smoothness makes the setting, kind of gives it a diffuse reflection. That can be nice, but I'm also going to pull this down to a little bit less metallic, just to make it a little less reflective. We play with it. We're going to build some other stuff. You can also see that the sunlight now is reflected in the floor. So we can pull that down and make it a little more diffuse so it's not such a big speck on the floor. Alright, one other thing you can do is you can take the sun, find where the sun in the scene is, and try to orient the light so that it's coming from the general direction of that location. Let me pull that back out of the way. We can also make it match the color of the actual sun. If we click on the color here and then use this little thermometer, we can go into our skybox and select whichever color we think represents the direct color of the sun. So now it's got a reddish color. Maybe we'll make that a little bit brighter, more white. So now we have kind of a sunset / morning rising, and it gives us this nice lighting on our guy. Alright? Excuse me. Alright, so now we have a floor, a sun, and a guy on a plane to sort of represent what we want to, where we want to start building. So we can create, for the first thing, we're just going to make a box, like a room for him to be in. So game object, 3D object, cube. We're going to leave it white for now. We'll scale this flat, make it kind of big, and then pull it out. It's pretty good. Then we can Control D to duplicate that. Oop. Select it, Control D to duplicate, and then we'll make a copy, and Control D again to make another. We're going to rotate this so it's the other wall. Let's see, make it 90 degrees. And pull it to one of these and just get it closed up a little. Doesn't have to be perfect, but you do want it to not have any gaps. And then Control D for this. Alright, now and then Control D again, and we're going to make this the roof. So we'll rotate it on the Z 90. Pull it, we'll scale it just a little bit to make it. So the idea here is we're trying to create this ambient lighting space. Right now everything's in shadow because of where our sun's at, so I'm going to go ahead and take the sun and rotate it just a little more. And if you watch the shadows in the box until we get some shadow going across the box, something like that. Probably as the sun goes higher in the sky, it's going to get a little brighter and wider. or more yellowish orange because of atmospheric diffusion. Maybe not that yellow. Alright, something like that for now. Pull this down, or leave it on top. Okay, so what we have, you'll see a couple of things and a couple of issues with standard lighting as it happens in Unity, this real-time lighting, because if you look at our directional light, right now it's set for this mode real-time. It's got an intensity shader, so you could crank that up. There's an indirect multiplier, and that we'll get into that because that's based on global illumination. So it just means that the bouncing of the light will reflect off of things in a way that gives us extra lighting, the way it does in the real world. So when light hits a white surface in the real world, depending on the diffusion of that surface, it'll bounce and start to light up other things. That's why we can get, you know, back walls and rooms and stuff lit up. So one of the things we can do just to simulate, you know, interior lighting in a space is we'll crank this environmental lighting down because it's going to be dark. In the outside it'll be lighter, but in the indoors you don't get as much environmental lighting from the outside. So I'm going to just make it like 2.7 because there's a big hole here, there's a little. We'll leave it at that. The ambient mode right now is set for real time in the lighting panel. So if I take that and set it to baked, Unity has this baked light option. So when we're real time, all these lights are calculating per frame, and that's eating up some of our processing power, which will slow your game down depending on the number of lights and number of objects and the shadows that are cast. So if we turn it to baked, we can take things that aren't moving in the scene and bake that lighting on the objects so that it doesn't have to get calculated every frame, which frees up a lot of processor. In addition, you're going to get better shadows because right now our shadow mapping from the real-time stuff, you can see there's these little gaps at the floor walls and stuff, things that are happening, and we'll bake the shadows as well. In addition, the shadow baking or the light baking is going to also give us our global illumination bounces. So if we select our light, right now the light is in the inspector tab here. It's set for real-time mode, which means it'll only light things in real time. It won't be considered for baking. We can turn it to baked and then it would only be considered for baking, or we can do mixed and it'll do both, and that's what we want just for this directional light. Other lights we may want to just bake. Alright, so now we have these soft shadows, and you can change these. The scale baked shadow angle is going to be the angle of the shadow, this diffusion that happens as it goes past an edge and over time slowly fans out because of light scatter. So we're going to set that to 3. The shadow strength will be 1. Quality settings, we'll go ahead and use whatever our scene quality settings, and these have to do with how fast the baking can occur. We're going to leave it. We're going to leave all these the rest of these settings besides changing the mode to mixed for that. And now, if we turn on lighting, our lighting panel, at the bottom you're going to see this auto generate. I'm going to turn that off. That means that when you make changes, it'll automatically start baking. Sometimes that can slow down your machine. I'm just going to generate the lighting when I need it so that we can keep working. And if I click to generate, right now nothing's going to happen. You're going to see it start to think about it. It did it really quick. The reason nothing happened is because, as I said, baking will only happen on objects that are considered not moving. And the way you tell Unity that the objects aren't moving is if you select them, this plane 2, and then go into the inspector. At the top there's this static option. You turn that, toggle that on, that will then tell Unity these objects don't move, so you can go ahead and bake the light on them. And let's see, there's other, I've got a bunch selected, so let's select one. Yeah, you're going to see in the when we turn the static on the object, it says Lightmap static. So you may have static objects for other reason and then not have this Lightmap static. It means it's going to contribute to the light mapping. So now, if we go back to our lighting, with all of these things turned on to static, and we click Generate Lighting, it's going to start doing this little render job, this little 511 clustering of one jobs down here. And this can take a while depending on the number of objects in your scene, your settings for your light mapping, all of these things. Right now it's set for kind of optimal, really nice rendering settings, which could take minutes, depending on the complexity of the scene, could take hours. So now the rest of this tutorial, I'm going to show you how to get this thing sped up so you can actually see the result and not end up waiting hours for your lighting to show up, because this is, getting your lighting set up and right can take a while, and you're going to have to do a lot of back and forth on it. And if this thing takes forever to render the job, you may just give up and quit on setting up your lighting. So I'm going to go ahead and cancel this. So no light maps have been rendered. You can check that under global maps. There's no maps here. The reason it's taking so long is partly because of a lot of different things. So if I set, let's take each one of these objects. In their inspector, there's a bunch of options under mesh render. Once I set up static and get it set up for a light map, there's options for how big they're going to be in the light map. These objects are relatively small. So like this, let's take this plane, for example. It's bigger than the box, so it should probably be bigger in the light map. It doesn't have much detail. And the light map, right now we're setting up for a 1024 by 1024 render. And it just is sort of like UV mapping. It's just going to tell you how much texel space. Texels are light pixels, let's call them. How much of that, how much lighting do you want this object to take up in the space? And right now everything is set for a size of 1, which means it's going to be a whole map for each object, which doesn't make any sense because we don't need that much. The light maps are kind of composited on. They don't need to be as big. They're more for like shading and environmental lighting. So let's just set everything, select all of these, and set them at, just as a starting point at 0.25, just to try to get the speed to go better. So oops, sorry, 0.25 on the scale on the light map. So everything now is set at 0.25, which means it's going to take up a lot less space and take a lot less time to render as far as global illumination goes. Alright, so now if we go back to lighting, we've got some options that we can set to try to speed things up as well. We have real-time lighting going on, real-time global illumination. We have baked global illumination. The real-time global illumination will happen as far as being able to tell objects that aren't set for static what kind of light we're getting from bounced surfaces. And we'll show how that's set up in a sec, but let's get our light maps going first. We have baked global illumination, which we definitely want. And global illumination just means that, lights are going to bounce around and light up things, and you'll see that in a sec. So here's where we can start to speed things up a lot. We have a render engine, 2 options for render engine. Lighten, which is going to make a nice map. It takes a while, and this progressive preview, which allows us to sort of see it build on the fly, and you can see the results quicker. Just to get an example of that, I'm going to set it for progressive preview. And you notice how that changes all of these settings. Then I'm just going to say generate lighting, and you'll start to see the maps as it renders start to develop, and you see where suddenly all these surfaces have changed color, and you see where I'm actually getting bounce light off of the back coming on this back wall. Same thing in these rooms, and it's slowly building. It's still rendering, and it gives you an actual estimated time. So it's 47 seconds right now for this. And we can sort of, bounce and look around and see it on the fly. So this is what global illumination looks like. So you see in the shadows where, this is really bright. That's the direction of the sun. And then on the back wall, it's getting shadow, but it's also sort of getting this bounce light coming from this surface where the angle is lighting it up. So you can see it's also calculating across the surface as we go. And then in the interior, it's the same thing. Actually, if you do it in the game views, the camera's not set up. Let me go and take the camera and move that into the box so that we can see it. And if we go to the game view, you'll see that we get these brightness areas, this setup across the edges that create sort of an ambient occlusion. Alright, one better way to see what global illumination really looks like is, let me go ahead and we'll let it finish out. It's got 17 more seconds, but we'll go ahead and change. We're going to create a new material, or in our materials. Let's see, I may have already created, yeah, I've got like a red and a green material, so we're going to show some bouncing off the wall. So if I take the red and drag it onto this wall, then I get a red wall there, and a green and drag it onto this wall, then we'll have a green wall. And now you'll see how it starts the baking process again. Again, it's going to go for 1 second, but it starts to, render. And you're starting to get some mix of color where the bounce off the wall is. I don't know, I'll show you in a sec. This real time, this preview is not a fast way to see it. It doesn't give you a good result. So I'm going to stop it. Let's cancel. Force stop. And then, alright, I'm going to set it back to enlighten. And the way we're going to speed it up is like these quality settings right now are really high, like light map resolution 40 texels. And I want to show you how you can visualize this. So with this light map resolution set to 40 texels, if you go to the shaded scene option right here under the scene, right now we're set for shaded. If we wanted to see wireframe, we can show the wireframe mode. We can do shaded wireframe, shadow cascades, and that's showing where the shadows are. Down here under real-time GI, we can see the indirect, and right now there isn't any because we don't have it set up. The albedo, which is the color, and you're noticing these checkerboards on here. That's the actual texel size. So if we do baked light map under baked GI, you see those texels are really small on the object. We're getting a lot of detail based on the size on the map. And that comes from this light map resolution. So if I change that to 20, notice how the texels get bigger and less. So less texels is better for speedy rendering. So this is looking, yeah, we'll see what that render speed was. We want to turn on Final Gather, which is going to give us a better quality on the render. Again, though, the ray count on that Final Gather, it's like it's shooting out rays on the last pass. That's going to kind of clean up the image and create more bounce light. It's set for 256. We can take that down to like 128 for a preview. Eventually, you'll set these things back to nicer quality for a final map because it's going to bake the map once, and then you're just going to have it. And you want a nice quality map for the actual final production, but when you're just playing around and trying to figure the lighting out, setting it for smaller, you'll get a preview, and that'll tell you pretty much all you need to know. So we set it for 128. We want denoising on. That's going to take the noise out of those light maps so you don't get as much splotchiness. And let's see. Default is medium for the light map parameters. That's fine. Let's try that and see what it renders like. So let's go back to shaded, and we're going to do generate. We'll see how long is this. So it's 7 of 17 bake visibility with one job. So let's see how it goes. Now it's at 11 of 17, 13 of 17, so it's cranking through it pretty fast. You could also take, if we wanted a smaller light map size, we could take the, so now it's created the light maps and they're on the box, and we get our, it's all baked now. Let's see, let's look. We'll look in the game mode. So if you look in the game mode, you see we get some red lighting bouncing up here, some green across this edge. It's looking okay, but we can probably make it better. But it's a nice start. So it's better than the default, because if you turn off this light, you're going to see that's what it looked like before, and now we're getting something that looks a little bit more final quality. Alright, so what else can we do here? We can create, using these materials, we can create, not just using lights, we can also make objects themselves emit light. So if I wanted to make, let's make a box. We're going to make it like a fluorescent light at the top of the ceiling here. So we'll create a 3D object, cube, scale it down, and I've gone and made this light material that I can drag onto it. That, all I've done is basically, if you look at the settings for it, is turn on emission in the standard material. It's got nothing else. It's a white color. The emission has its own emission color. So if I wanted to emit like yellow, I could turn it to something like that, and probably make this yellowish too. And then I have the emission amount. So if I crank that higher than 1, you notice when it says HDR, and that's basically forcing HDR rendering into the channel, and that's good because we actually get better quality lighting that way. So I'm going to just crank it up to like 1.124. It'll make the light a lot brighter too. And then we just tell it if we want global illumination from it to either do it in real time or do it as baked. So we've set it for baked because it's, and we need to make it a static object then, so it gets considered. And then we'll pull this up into the ceiling, just something like that. All right, and then we can go and render again. Oh wait. One other thing though, is we put that in there and notice that its scale in the light map is 1, so let's make it 0.25 because it's really small. And this is where you can really start to optimize your light maps by giving them the textures. So if we go to lighting and we look at our global maps, these are the light maps that rendered. So because we told, let me pull this up bigger, see if you can see it. Or we can do it this way. There's a directional, a light, and a shadow mask. I'm going to open it with, I guess I'll open it with Photoshop, see what happens. Yeah, sure, is Alpha channel. So here's our light map. And you see where, because I told things to be a certain size, this is the size on the light map right now. This is the full size. So here's actually where the mapping on the plane comes in, and it's how it's mapped out on the plane. So it's actually getting light bouncing across on the outside. This is the interior. This is the front face where the sun's hitting it. So you're getting less green here, and then these are the interior parts of the walls, how they've been sliced up. So if you take, just to show you what I was talking about, there's a little bit of bounce light going on here, but the checkerboard, you're not really seeing it. Let's see in the game. you don't see, for some reason, and I can't quite figure out why, this preview in the scene mode is set for a lower resolution. There's a lot of banding in the color, but you don't see it in the actual game version, so I'm not quite sure what's going on there, but it's probably just a speed rendering option. So let me check my camera. I just want to check and make sure my camera is set to use HDR. Yes, if you have, we can turn off this allow MSAA, that's anti-aliasing. If we do allow HDR, have that checked, so that way we actually get the HDR lighting and it'll show it. And that's probably why I'm not seeing it here. So the HDR is showing, is getting rendered for the, and probably pre-computed for the actual game view, but not in the scene view, which would cause banding because it's not capable of showing the HDR texture. So, let's see here. Oh yeah, we had our light. Let's assign it. It's got a small spot on the light map, and let's see how that renders in our scene. Generate lighting. It's going to go through the process again. I didn't notice how long it took the last time, but it seemed like it was less than a minute. You know, once you get more complex scenes, it's going to take a lot longer. It's just the way it works. So it's 5 of 11. And what will happen this time is you should see like a pretty bright area start to get illuminated on the ceiling, and it may carry on and like light some of this back wall and down onto the floor. 5 of 11. Let's see. So while that's rendering, I want to show you something else. I'm going to go ahead and add a sphere. 3D object to sphere. I want this sphere to be real time. I don't want it to be lit as a static object because I want to actually animate it moving around. So I'm going to pull that out into the light. You notice that it'll take the shadow, but it's probably not going to gather any of the lighting data. For that sphere, I'm going to make a new material. Go to, let's close out sample scenes. I'm going to make a new material, and we'll call this metallic tech. I'll drag that onto the sphere, and so what we can do is we can crank up the metal and the smoothness, and we're going to get, you'll see we have a rendering now of just the environment. So I'm not getting any of these objects around him. It's not showing, those aren't showing up. And if we want to see in the reflection, if we want to see this reflect the actual room that it's in, we can create an actual reflection object or a reflection tool that allows it to measure, sort of probe the environment and get the reflection that we want to project onto this. So in order to do that, you select game object, light, and then there's this reflection probe, and that will create a reflection probe of the room. It's kind of below the rim right now, but we'll pull it up into place. And notice that as soon as I created that, I started to get a reflection on the ball here. What we want to do though is we want to set it up so that it's optimized for the room. So here's a representation of the reflection probe. If I select this, this is what a reflection probe icon looks like. If you click on it, you actually see the reflection probe, and you can edit the way it grabs its data. Right now, it's going out to infinity, and it's not set up to grab specific space as far as being inside of this room. So if I want to scale it bigger so I can see it, I can make it smaller. We'll just leave that. We want to edit these bounding boxes though and make it actually work better. We can click on in the inspector. There's this little edit bounding volume. And when you select that, you get this box that allows you to pull the edges around on the probe. And since we're in a room, and this is a box, it works out well, we can pull this just to inside each one of these walls. Which should give us a better reflection. And you'll see why in a sec. You'll start to see. I'm going to pull the top down into the ceiling, and then the bottom will go up into the floor. Actually, we can pull it just a little bit below the floor. So then, we still get this, let me move this ball around and I'll show you what that looks like now. So as you move this ball around, you see that the environment doesn't change its position. I mean, it changes relative to the camera view, but it's not changing relative to the actual wall size. So if I pull it up right next to the wall, that wall should start to take up the majority of this reflection. It just doesn't because of the way the reflection is set up on the probe. So if I select that probe, there's an option called, where is it? Box projection, which will work well for rooms. It won't work for other things, but since we're in an actual box, it should work pretty well. Now watch what happens to the sphere as soon as I click that on. Notice how it shifted its position. That's the reason we set these bounds up, is because we wanted it to be a box projection and we're determining the box that's actually going to be projected. So if we take the sphere and move it now, you'll see where the reflection actually starts to represent. When I get close to the wall, it starts to go really big. And actually, let's turn the reflection probe from baked to real time just to see. It should be like, okay, so it's doing a projection from the center then going out. So if I pull it up close, it's grabbing that plane there. And that's going to show up in real time. So the real time settings you can use, and basically you're going to get some nice things like it'll allow real-time objects that move around in the scene to show up in the reflection as well. So if you look at, you can see Adam sort of barely down there. Let me make him a little bit bigger. So he shows up a little bit more. And so he's there in the menu, so the quality and the view. You can see the view for this reflection probe is set pretty low. Right now the resolution is 128. That's fine, but for like the more reflective your objects are, the higher you may want to make that, because it's going to be kind of pixelated. So you can take it up to like 256 and you'll see the quality get better in terms of drawing. Alright, so now back to where we were. We're going to leave that at real time so I don't have to bake those maps. Let's take this sphere and edit the quality of the material. So since it's set for it's not static, it's real time. We wanted to animate around this room and take the quality of the lighting as it moves, but because it's real time, it doesn't understand how to grab the lighting from the baked map. So what you can do to fix that is you can create what's called a light probe. So in order to do that, see right now if we move out here, it just stays equally lit as I take it across the shadow boundary. The reflection kind of takes on some of the lighting, but not as much as you might want. Especially if we take this and turn it into something a little bit more diffuse. So if I make it kind of a diffuse ball, let's give it kind of a gold color for now. It's sort of a golden ball with a slight blend. Notice that it doesn't really take the lighting. The sun disappears as I go behind the shadow, but it doesn't change the diffuse quality of the ball. Because it's set for completely metallic, but if you did a more plasticky ball, you're getting shadow, but you're not really getting any bounce lighting from this red wall. The way we can fix that is, let's just leave it. Let's go full metallic on it. We can create what are called light probes. So if you go to, and they're similar to a reflection probe, but you have to actually like tell it where you want. You add probes to tell it where you want to kind of catch that light. And I'll show you how that interplays with these real-time objects. So if you go to Game Object, Light Probe Group, you get this box. You want to move it to the center of the room, and it's got 4 probes, or 8 probes at the corners. So it's basically going to just probe out to the edges. So I'm going to take this and scale it to the edges of the box or the room. Yep. And then the same thing here. So it's not going all the way to the back. Make sure you don't go through your objects. Then I'll scale it to the corners. That's pretty good. So this sets up a reflection probe that'll sample light at each corner. Now if we want to add probes, we can just click on, in the inspector, click on Edit Light Probes, and you get this option to add a probe. And that adds a whole new probe that we can then just move to sample, like say where the light transitions from into the shadow. You can add another and pull that to sample, and you're just going to want this at the spots where you need to sample. So like there's, put it there into the light. You can add another, and we'll pull this one and put it sort of in the shadow, and then another one at the edge. Like that. We can put one up near our light source here. So that we actually sample that. Probably want to put one a little bit lower and around it, so we can just duplicate. Let's duplicate that one, and then pull that one down so we get one closer to the ground, even down here, and that'll set up a relationship between those two and the corners. And then we can duplicate that one again, and we'll sample out here to the where the light hits the floor. Duplicate again, and these I'm just basically trying to set up a relationship to the actual environment, like a reflection probe. But the more of these you have, the better the real-time mapping will look. But also the longer it'll take to calculate. It can bog down, but they're pretty efficient. So you don't have to be like, you don't have to throw them everywhere. It's just basically throw it where the lighting changes. Probably put some here. Select this one and then duplicate that. Pull one to there. And then duplicate that one up to something there. Maybe duplicate it again and pull it out into the light a little bit. And then one over here. So you're kind of creating this light mesh that's going to create a bunch of cast rays for sampling. And all that's going to do is just measure the environment of this box, this room. It's probably good enough for now, but I could probably use one more up here. Oops. And then I'll pull one into the room, or into the shade. Alright, then we'll pull one against this back wall. Alright, so we have this light probe set up. It's kind of a mess, but you'll see what happens when I actually go to bake again. So what it's going to do is end up creating this light probe. Each one of these is going to represent an interface, so I can see if I select the sphere, right now I'm not getting any kind of interaction between it and the light probes because I haven't baked the light probes. So let me set that up. I'll bake it. I'm going to bake them. Let's do it at 512 to see if we can speed this up. Or actually, let me check my baked light map quality. So yeah, maybe this can... Each one of these is set for 0.25 on the light map, and what we don't have is this UV charting control we can optimize in real time. So if you turn that on, it should change when it's actually baking to kind of optimize the light map for each one. It'll optimize the UVs. Can take a little bit longer, but I'll turn that on and see, because maybe it'll go smaller then. Let's also take this. It's pretty good. All right, let's see if we can calculate based on that. Shaded. And then in lighting, I'm set for a light map size of just 512 now, which is going to take the quality down a bit, but should calculate faster. And my light map resolution, I'm going to leave that up there. One thing I can do to kind of increase the effect of this indirect bouncing is I can take the number of bounces up to 2, which means it's going to bounce, and then it'll bounce again, which will create more indirect color. So I've gone and clicked generate. It's going to go through and render this batch. It's rendering the reflection probes. And we're done. So now we have our scene rendered. Now you're starting to see a lot more light map bouncing, nice shadows. Alright, so now when I select this sphere, you notice that it starts to show how it interplays with the lighting. If I move it, it's showing which light probes it's actually interacting with in terms of taking its external lighting in real-time GI from, which looks good. Same thing with this guy. If I move him, he's should interact. Maybe because he's a character he doesn't. Or maybe the objects within him. Yeah, so the objects themselves are actually interplaying, but because he's a group, it's not showing it on the group, but that's okay. But he's getting real-time illumination too, so like if you see him, when he gets over here, he's going to be really lit from the red. If I take and deselect, he's going to be getting more red from this face, and if I move him to the green, be getting more green over on this side based on his materials. So you see the green light starting to affect the white on his face. So that's how you can set up these lighting relationships for baked objects and for real-time objects. Is this thing set for static? For some reason its emission's not really going very bright, but we'll show you a way to light that in a second. So the other thing you can do is once you've got this thing baked, you can change the material and it'll still, if you change the metallic quality of it, you can make it more reflective and you'll start to see the reflection in the room because of the reflection probe. So you see where it's getting this, it's kind of weird because the guy's showing up all distorted and big because of the location of the reflection probe, and it's because it's real time. But if you blur that a little bit, you can't really tell. So if you want, like, for some reason you want some metallic looking walls, or you have some metallic qualities to your walls based on these control with these maps, then that'll actually show up with a reflection probe. So for now I'm just going to take that down though and make it more diffuse. Have a little bit, yeah, something like that. Okay, so the last thing I want to do for the purpose of this tutorial is show you how to animate this guy moving around. He's going to be like this floating robot. In order to make him a robot, let's actually add a texture map, which I have here, this copper. I've already uploaded copper circuits. We'll do this diffuse, so you see how that's kind of got this quality to it that's circuity kind of texture. And one other thing, if you look at the textures, the way you make these textures, if you select them in the inspector, they have a control for an alpha source, which if you look at the material has some meaning, because you can actually stack your textures so that it pulls another control from the actual same texture. So like the color map, the non-alpha channel imagery can go to the diffuse, and we can get our metallic quality from the alpha control in that. But right now, based on the way this texture is set up, the alpha for this copper circuit's diffuse, it doesn't have an alpha channel. You can tell that if you look at this preview by selecting the texture. If you look at the preview, it just says RGB. If I've got one next to it, it does have an alpha, but this has to do with how Photoshop exports PNGs. But you see it's got an alpha map. So if I apply that to the material, this copper circuits, copper metallic tech, if I take the texture and apply that copper circuits metallic to the albedo, now I actually have like a color that shows through, and I'm getting a metallic reflection from, and the color's coming from this. So I can take that and make it white. And I'm getting my metallic from metallic alpha, but if I wanted to get it from the albedo alpha, which is the alpha channel that's actually on this map, I can select that, and suddenly I get this control where I'm getting metallic color from the alpha map that is coming from the image. Now another way to set that up though is if I actually just apply this copper circuits diffuse, or this copper circuits with this darker color to it, probably would be better. If I look at that texture, it's set for the input texture alpha, but I can also set it just to get from the grayscale of the texture, because it doesn't actually have an alpha channel anyway. So I can just take, you know, the RGB quality of it, one of those, and use it as a grayscale, or it turns it into a grayscale. So now if I take that and apply it to the material, metallic tech, well, I've got to apply that setting that I just did to the material. If I take this copper circuits and apply it to the albedo, now I'm starting to get metal where metal is, and not metallic reflection across the rest of the surface, and I'll show you how that can work. So if I take the smoothness because I'm using the Albedo Alpha, which I set up to be just a grayscale image coming from this copper circuits. If I take the smoothness down, it's kind of hard to see because of the reflections, but I'm getting some, I don't want to get smoothness across this dark stuff. So I use the Albedo Alpha and crank up the metallic. And this, to be honest, this Albedo Alpha is not working. This image that I'm using for this isn't working so great, so I'm going to use the copper circuits diffuse. Whoops, I accidentally clicked on. I need to drag. So select metallic textures, copper circuits diffuse, and drag that into the albedo. So then, what's this set for? It's getting its texture from its input texture alpha, so if I set it from grayscale and apply that, notice how it popped and changed, and now I have this sort of reflective quality coming from the grays of this image. I'm not really doing a good job explaining this, but it gives you the ability to sort of, you have to use the alpha control, or I can take and just use this metallic control, and I can apply a separate material. So in this case I have so copper circuits, I have this copper circuits reflect texture, which is a dark gray image, and I can just use that grayscale. So what's going to happen is it's going to create this color reflection out of this, and yeah, the color reflection would be like this grayish color, but then I can also use the alpha, input texture alpha from grayscale, set it for that, and then apply that to the material. So let's go to metallic tech, gotta apply. If I put the copper circuits reflect in the metallic control, so suddenly I'll lose that control, and I'm getting my source from the metallic alpha. I could also get it from the albedo alpha if I had it, but you see the difference. It gives me a little bit more of a circuity look across this object, where the circuits are more reflective than the stuff below. It's not great. You have to play around with the controls a lot to get it to work. So maybe it's, I could do copper circuits, because the part of it is that I'm applying now metallic, and metallic reflects the metallic color. So by applying this gray to it, it's kind of graying out the metallic color. So if I do this copper circuits trans to that, let's see what happens. That then applies the metallic color to, and I'm using the metallic alpha. And then I start to get sort of these wired circuits across it. Now, it's okay, it's not great. I'm super reflective, so I can dull that a little bit to help make it look more metallic, especially for copper. One of the other things I can do is I can add a normal map. So a normal map is just looks like this. You generate it from, you can do it in Photoshop with the 3D filters option, but basically it's a RGB channel that takes and shifts the normals of this object based on the color from each RGB. So if I take and apply this, to the material. The other thing is when you import these normal maps in, you have to make sure you declare them as a normal map, otherwise they won't show. So they come in set at default. Let me apply that. So when I apply that normal map now to this copper circuits, so if I take and drag that and apply it to the normal map, I get this map, and but it's not quite right. So if I take and then go and apply this, make it an actual normal map, you'll see how it starts to pop. It basically gives it sort of a bump. But let me select And then I may not want that much bump, or I may want to. So if you change the amount of the normal map, you'll see how it starts to shift off the surface. Give it a highlight, or you can make it recede into it. So I'm just going to apply a little bit. You could also apply an ambient occlusion map to make the inner parts darker. You just have to render those. Anyway, that's how you start to set up these metallic looking textures, and you can tile them. So I can make it tile more across the surface like that. But I already made one earlier that I kind of liked. So this copper circuits, if I take and drag that onto it, then you start to get this metallic looking ball that has kind of a reflection too. So we'll go with that. Let me see. So I've got a normal map, I've got an occlusion map. I can take that occlusion map and turn it up or down. And then I also have amount of reflection. Getting it from this metallic alpha, using this metallic transparency. And actually I could probably brighten it up a little bit by changing the albedo to be coming from just the copper circuits diffuse. Let me see what that looks like. And then crank up the occlusion. Yeah, we'll go with that for now. Maybe go 1 on the UV mapping. Alright, we'll say that's good enough. Let me save the scene. Save the project. So now I want to animate this guy. If you select sphere, and you'll notice I've got the timeline hidden down here. So I'm going to pull this short. Maybe I'll just move my project window over to here to get it out of the way so I'll have more room. So I've got the sphere selected and I want to hit create. It's going to ask me to create a timeline playable. I'm just going to save that in assets for the sphere. And we'll say, let me change the name. Timeline 1, because I've already done this once. Save it. Alright, so now I have the sphere and I want to animate it moving around this space. So in order to animate it, there's a couple of different ways I can do it. I can apply a preset animation, or I can just hit this record option, and now I'm recording. So I just take and move the sphere in space and it'll create a keyframe. Also too, I'm looking at frames. It doesn't really tell me much in terms of seconds, so I can change the frames under this gear pull box on the right to seconds. So I see what I'm looking at here is 30 seconds. Shift it off the screen here. So 36 seconds for here. Wait, is that right? Where's that 1 second? Yeah. So 30 seconds. So let's do movement. Let's just see what happens if I move this guy to here now. So it'll create a new keyframe. I'll move him over to the edge. If I hit play, let me stop this. How long is that going to take? I just want to make sure my timing's right. So hit play, it's thinking. Not sure why it's thinking so long. It's not lighting, hopefully. Here we go. Oh, so it went really fast. Do it again. Yeah, it's too fast. So it's actually, it's not the amount of time that I thought it was. Let's go ahead and select. We're going to do the sphere, and we want a key. Oops. Oh wait, I'm still in play mode. I want to stop it. I want to select and record. Let me get rid of that key. I'll just delete those. Actually, wait. Let me step to the next key, delete key. Whoops, I deleted the entire object. So step to the next key, delete. It's because I deleted the whole thing. I want to select, delete the entire key. Okay, now we've lost that key. So let's move out to make it take 5 seconds. It's going to be relatively speedy, but we'll move that to there. You notice that it's got this automatic Bezier easing. So then we'll go to 10 seconds to move across. Go to 15. To here. 20. So you can do this, you can use this to create like artificial AI. So if we want to get this last key, we'll copy this first one. Copy. Select these and copy. And then go to 25. And actually we'll just pull it to here and we'll see if it lines up. There's a way to copy these or even just set them. So if you set the position 3.07, copy that, and then go to the last keyframe and paste 3.72. That'll get it to the right position. Same thing for the other settings. 2 points, copy. And then go to the last, 2.839, and then Z will be different. 0.07, copy, and then go to, yeah, that one would have been off, paste. Alright, so now we should have a looping animation. If we want it to loop continuously, you can select the playable director on the sphere over here in the inspector. And there's this wrap mode, set it to loop, and we'll save, and it should play now. Let's see. So here's our moving sphere. Alright, so it's moving. Now we want to make it so that we can actually see this thing. So I want to take the camera. One last little thing. I want to apply what's called a camera post effect option to it. So I've got this add component on the main camera. I can select effects and then post processing behavior, and it's going to look for a profile. I happen to have one, or you can create one in your assets. If you say create, and then I believe, let's see, Cinemachine, nope, probably under Effects. Post-processing profile right here. So if we make that, let's just call this test scene profile. And we take that and drag it into our post-processing profile editor here. So test scene, there. Now if we select that, we're going to have a bunch of options. So I want to turn on anti-aliasing, which will make the edges nice and smooth. I can turn on ambient occlusion. If you see what's going on in the scene, it's real subtle. Let me get in there. It's actually turning on like this darkness in the corners. We'll go ahead and leave that for now. We won't do screen space reflection just yet. You can create a depth of field, a motion blur. Eye adaptation is kind of cool because it makes this lighting change as you go into darker areas. It will get brighter. So you notice that as I'm looking in one direction, it'll brighten here, and then it'll slowly get brighter. So we're going to leave that on for now, and then I'll turn on bloom also. So bloom is this film effect that is the quality of film. When it gets exposed, it creates this kind of bloom where brightness or bright things kind of get fuzzy. It creates a more film-like look. So you can change that. Gamma. Intensity. We'll leave that. But the quality of the two together can look pretty good. You can also add a texture, this dirt texture, which will be like dirt on a lens, which can look kind of cool. So we'll like dirt, lens dirt. We'll do this one. And you can crank up the intensity to sort of see what that looks like. You'll see it more when we actually run the camera here. Actually, it may be that I used a dark one, but let's see. Try this one to get a bokeh. And then this color grading is just for changing things. So if I wanted to do like a filmic look, it's going to create a darker kind of film color. This is where you're going to create the final coloring of your scene. We'll play around with that in a different tutorial because there's a lot to it. And then finally you can apply a vignette, which will darken the edges, which can look cool. Alright, let's save that and we'll play it. Let me put, I'm going to take from my standard shaders, I'm going to put a first person controller so I can run around in this box. So standard shaders, where are we? Standard assets and first person character prefabs. I'm going to put an FPS controller in here, which isn't going to have my camera option that I just set up. So I'm going to turn my main camera off. Just turn off that tab. And then I'm going to take the first person controller's camera and add that same effects processing behavior, and then apply a test scene to that, and then I get it back. Alright, so let's just see what happens. So I've got my first person controller, I can look around, you see how the lighting is adjusting. So if I look up, it gets bright. Here's our moving ball, so I can go into dark areas and it looks good, but then if I look from dark to light, it gets bright, but then it lightens up. And this is reminiscent of the way your eyes adapt. See how it sort of ramps down. You can see our light. The bloom gives the light on the ceiling a nice light quality to it. Our quality of our light maps is not great, but that's because we cranked them down so low, but just for the purpose of this tutorial and rendering fast. So he doesn't have a collision mesh on him, which is why I can go through him, but anyway, that's how to build basic lighting setup and do some animation. And there's room for improvement because of the way this box is constructed. We're getting these weird maps, but that's all fixable with a little bit of tweaking. You can see when we're really back in the dark how bright that light outside gets, and it adjusts. Alright, that's it. Hopefully you found this tutorial useful.